Hello everyone and welcome back. My name is Mario and like always, I hope all of you are doing well. So yeah, in today's video, we're going to talk about complex forms in 3D modeling. So usually, let's say if you're a beginner and if you're just starting out, there is a good chance that you're going to struggle a lot with creating something that's, let's say, more complex or that has, let's say, multiple objects attached to one another. And in this video, we're going to try to answer some of those questions. So how to start to build anything complex, how to simplify those forms for us, and which parts should we practice before, let's say, creating anything complex. So the big emphasis here is going to be on mastering the basics. So having a very strong understanding of the basic rules of 3D modeling is always going to be more beneficial, let's say, starting at that beginning stages of learning. So let's say, again, if you're just a beginner, if you're starting out, the emphasis is going to be always on mastering the basics and having the strong understanding of basics of the topology before starting to create anything that is complex looking. So what do I mean by that? I have here a couple of examples prepared, and this is the example that we're going to cover. So starting, let's say, with this one. So let's say that you saw something like this online and you are just starting out and you would like to recreate something like this for practice. In case you're not sure where to begin with, what I would always recommend, start to kind of like break it down into the basic, kind of like the simplest forms or the first forms that you do not understand. So let's say if this piece right here, or this, let's say, detail right here is not clear, or you're not really familiar with, let's say, the workflow necessary to create this detail, you're gonna start with that detail first. So ignore every single shape that is attached to it. You're just going to focus sort of like on that form alone. So just take that, let's say, start with whatever you think that it might be, let's say, the beginning stage to establish that form. So you're going to create, let's say, either the form like this, and then you might try to do, let's say, support loops here. So let me do it one more time. And once you have that, probably you're going to want to add, let's say, different redirections. And this is now, again, what we're talking about, kind of like having those strong basics just to understand which kind of corners are we getting. And then from there on, we're going to try and kind of like populate, let's say, the topology just to see that we kind of like match more or less the corners that we're trying to get. And then from there, so now we need to continue further and think in terms, okay, so what is happening here on the inside? And we're just going to try to kind of like match whatever it's happening on the inside. So let's say we're going to select all of these parts and let's say extrude. And even if we're not getting there, again, maybe play with the scale. And this is kind of like that part where we are just taking a simple piece and see how far we can get with those so like simple pieces. So once we have that done, so let's say once we kind of like did that case study, we can continue further. So if I'm not sure how to, let's say, build this piece on the top, you can either use, let's say, a Photoshop or whatever, just kind of like isolate that piece alone and then try again to do the same process. So if you're not sure how to build, let's say, this piece alone, you're going to isolate that piece. And then once you start kind of like exploring deeper and deeper, so if you're now familiar how to create this opening or this one, then you're going to continue on the full piece itself, ignore all the details and just build the piece itself. Because what you kind of learned from sort of like exploring these random little details is that they will give you sort of like the direction of the topology that you're going to need for that part. So you're going to need to know, okay, so if this is the part that I'm recreating or this is the detail that I'm going to need to later, then that means I'm going to have this density of the topology for that detail to exist. Because if the topology is lower or denser, this detail might look different. So once you know the detail, once you know the topology requirements, you're also going to be much more prepared if, let's say, recreating this part alone. Then you're going to need to know from advance, okay, how much topology do I need to know, actually need to have on that object to support that detail. So basically, then that is going to be kind of like that progression. And then same thing goes further. If you're not sure how to, let's say, create the lower part, you're going to isolate it either like I mentioned in Photoshop or give it some kind of like color value to separate it from the rest so that you know that you're focusing only on that piece. So again, if I just kind of like select this part alone, then this becomes my focus. So I'm now focusing only on this piece, and I'm sort of like trying to model this piece alone. So even if I want to, just try now to find the part here on the top to kind of like make it even easier for myself. I'm just going to kind of like deconstruct these pieces alone. And once I have all of these parts together, so once I kind of like have a bit better understanding of which pieces need what sort of topology, then I'm going to think in terms of, okay, so let me now try to connect all of these pieces together in a simple form, so ignore the details, practice kind of like putting it all together, maintaining the clean workflow, the clean topology, and then the same thing, just continue forward with adding those details that I initially sort of like practiced out. So, and then that is kind of like the general progression that is going to be to creating something, let's say, complex from that, let's say, practice standpoint. So the same thing is going to work, let's say, for this one, or even for this one. Let's say if this is the object. So again, all of these parts, you're going to see that we covered, I think this one was even the video before. I think the video before this video is actually talking about Maya UI, but the video before that, we covered this example right here, which you see on the screen. So again, you will take, let's say, just a single piece from here, and then try to model that and deconstruct that the best you can. And if that is proving to be challenging, then what we're going to do is we're going to take only one piece and then practice this piece alone. So let's say take a cylinder and do the extrusion until we are kind of like sure that we understand that. And again, same thing is going to be the top, kind of like separate only the top, modeling the bottom, and then try to figure out the ways to kind of combine the top and bottom together. So this is going to be sort of like the general mindset behind deconstructing every single kind of like complex piece that you see when we're talking about sub-D modeling. You can also do, let's say, assignments for yourself, like you can do something complex in CAD where you don't need to think, or with Booleans even, where you don't need to think topology that much, and then deconstruct those pieces in those kind of like terms where you kind of like start with the pieces that you don't understand, deconstruct those, and then slowly kind of like build the puzzle together. Same thing again would be with this one. Again, if I'm trying to put this together, I will deconstruct it in, let's say, 2-3 parts, or regardless of how many parts, it's just going to be based on the parts that I do not understand. So if I'm not sure how this piece is made, I'm going to isolate this one and just try to create this one as a, let's say, solid surface, just to be sure how much topology I need when it comes to the sense of adding it as a detail to something that comes later. So once I'm familiar with that, I can move forward, deconstruct this one, focus only on this part, and then work again through the same kind of like the same process till I'm familiar with how this piece works, and then I'm going to start thinking about putting those pieces together. All right, so with that rule in mind, we can start thinking about, let's say, this piece and how we would deconstruct this one and how we would, let's say, recreate something like this for practice purposes. So again, we would start with a piece that probably is going to be the most challenging, which is going to be, let's say, this part right here. So if we know how to create a cylinder and how we can, let's say, create an extrusion from the cylinder, then it's also going to be easy kind of like to understand how to not just wrap it around the cylinder, but how to build it on top of the cylinder. Because in the previous videos, we talked a lot about, let's say, simplified topology. We talked about subdivision surface, and there was a lot of comments about building something on a flat surface and then wrapping it around. But sometimes that is not always going to be the sort of like the valid approach, where sometimes we are going to need to build things that are on, let's say, the curvature or cylinder itself. So in this case, how the practice would look like, it would be something like this. So again, we would take the cylinder and then we would do a small case study on that cylinder based on, let's say, redirected edges or non-redirected edges, depending on what we would need. And that is what I meant at the very beginning. It's going to be extremely important to have a strong basics and just mastering the basics of the topology or the general topology workflow, because where that comes in play is exactly here. So once we're starting to deconstruct those complex parts, we are doing these case studies where we are trying to establish a corner, which is going to be either non-redirected or redirected, in which both give different results. So obviously redirected one is going to be sharper corner, which is going to give slighter pinching, where non-redirected is going to be sort of like more smoother corner, and that smoother corner also is not going to give us any pinching, and it's going to give us, let's say, more of an ideal presentation of what we need, especially if we're looking something from a larger distance. So if we are, let's say, comparing this to our reference, or if we're using a reference, we're going to see that here the corner itself is not going to be that sharp. So again, and it's not showing any signs of pinching. So by that manner, we are probably then going to use kind of like that regular, regular corner that we saw. And let me just show you again in that first example. So we are kind of looking for more or less this corner right here. And again, if we need to tighten it up, then all the, let's say, tightening is actually going to come from the support loops on the side. So this is something that we're looking for. Obviously, redirection is also, let's say, part of an option if that is something that is required. But if we know both approaches, so if we kind of like did this as a test just before we started, then we already know what to look for, and we already prepared for the shape that is coming. So there's not going to be any surprises, and we're not going to be sort of like left on the spot when we are starting to create that piece. So let's now start and do something with it. So I'm gonna start with the cylinder, 24 sides. So usually with the cylinders, so this is also good practice that I recommend, is just when you're practicing cylinders, try with 20, 24, 28, and 32 sides. So this is kind of like going to be the golden middle. And then from those, you're going to either subdivide further if necessary, or it's just going to leave them as they are. So usually, I don't know, I start with 24. This is kind of like the golden middle that I usually go with. And if I notice that, let's say, the geometry requires something more, then I'm going to increase or decrease the topology. So the next thing, what we're going to do, I'm going to snap this to the corner, because what we need now is we need to set the middle. So the middle is going to be here, and that means that this cylinder needs to come to this corner right here. So it needs to be here. Also, the cylinder sides are so like set in the intervals of 4 for the reason that we can always separate that 1/4 and delete the rest, so we can only work on that, let's say, one piece, and then simply mirror it to everywhere else what we need. So here I will just again increase the size, because we are also going to cut this in half too. So we're going to cut this and this, and I'm going to just take this one, hold move, and hold V on my keyboard to snap it to this edge. So once we, let's say, cut it in half, we are just cutting it on a proper side. So that's kind of like the general thing what we're looking for. Since we're using booleans, I'm going to keep it as is for now. So I'm not going to do it just yet. But once we apply boolean, then I'm going to use that. So let me just increase this. And again, we're going to need mid loop here, and I'm going to need a mid loop here. And then setting it here down. Same thing we're going to need here at the top. So just, let's say, create a cut. But actually, you know what? Before we do that, we need to discuss something more important before we actually add this loop. We need to see one important thing. And that important thing is going to be where all of these parts sort of like meet. So if we, let's say, see it here, we are sort of like looking for not this. So we're not really looking for where the points are meeting like that. So because we're going to have, let's say, this, and we're going to have this loop here. And then on this part on the top, we are going to have a loop here. And then we're going to need to have a loop here. So basically what we are doing is sort of like preparing ourselves for that Boolean operation. And since we did that exploration before, we now know what kind of corner we would need to happen here. So that means that if we would have this, we would need to have a redirected corner, which goes here, this would go here, this would go there. And then we would have a situation where this is not really matching and this part is stretched, and that would mean that this edge loop here would need to go to this one. So that means that this edge loop would actually need to go here. And this is really not something that it's working for us. So I hope that makes sense. So instead, what we're going to do, we're going to scale this a little bit down. Let me just, so we're going to match it more to somewhere like this, let's say here, because this is actually matching more and it's looking closer to what we need. So again, if you remember that what we select this as a small test, it's going to be something like this. So we're going to have here an edge, which is going to continue. This one already exists. We're going to have here an edge loop, which again just continues there up. This edge loop continues there. And then what it's happening is that this one connects here actually from this one. So ignoring that one for a while. And now it's then much clearer what kind of like loops are we getting. So now if we add a new one here, then this one will just continue. And we have basically no problems with creating, let's say, a softer edge, because now once we are tested everything on those basic case studies, now we want more prepared for this situation, and we don't need to kind of like think on the spot. For that reason, like I mentioned, I would highly recommend deconstructing the complex pieces into small pieces, do a case study on those basic parts, and do as many studies as you can. So once the part comes like this, that you just prepared and you know already what to do, and you're not kind of like left on the spot. So I can just quickly then remove all of this because we don't need that. All right, so now that we have that set up, let's prepare a little bit more. So before adding the Boolean, let's just sort of like also prepare some of the loops that we're going to need to have around these areas. So we're going to need to have this loop. So let me just also just use V to snap it to this point. And here we're going to have one support loop, which is going to be matching here. And then this one we can just extrude till here, and then later we're going to fix that as well. So here we can also maybe increase it a little bit more so that these points match more or less. It's not a big deal if they're not perfectly matching, because the tolerance here is extremely small, so we can still get away with that. So again, just maybe match this here. And at the bottom, it really doesn't matter because we are going to cut it here in the middle anyway, and sort of like simplify it even more, so that later, once we're done, we just mirror it then on the y-axis. So again, what we're doing here is just sort of like preparing for that Boolean operation that later we can detach, let's say this only 1/4 of it all, and work on that. And also then further down the line, just cut this in half as well and work only on that top part. So now again, what we did is sort of like prepared that now when we Boolean this, we're gonna have already prepared, so like this cut right here. So everything is already established, and that is all. So let me just undo all of this, and I think that is all. So we can now select both and simply use Boolean. So Boolean union, and that is it. So what it's now left is connecting or detaching the bottom. And if you see this green thing happening, that simply means there is no material attached. So we're just going to attach the material. And also what we're going to do is cut this and cut this. So detach and delete. So now we can work only on this part right here. In addition, we can also cut this in half. And we only work on this half. And again, just simplifying everything that we can and just work on that small piece. All right, so what we need to do now here is we need to deal with the topology that is open. So since the tolerance here is extremely small, we can just go ahead and snap or target weld these parts together here, because it's not going to be that visible if any kind of curvature is lost. And here, now we just connect this, what we already kind of like planned ahead of time. So here, now we need to sort of connect all these parts. So here we're going to have a couple of edges. So we're going to have three edges. So we can also do it like this, just to keep it a little bit more organized. I'm trying to delete this one here. So we're going to use 3 like this and then connect it here, just to keep it a little bit more organized. And then this one, for now, we can connect right here because we didn't really solve anything what is going to happen here. And even though that this is a triangle, it's not that big of a deal. So we can also maybe create even one more here and connect it to here. Doesn't matter for now if it's triangle, we're going to fix that later. So right now it's only kind of like the important that we connect all the points together and that we get sort of like the solid shape out of it all. So now it's all up to sort of like the fixing things. And since here we have this kind of like sharp triangle, what we are still missing though is going to be a support loop here around. So the support loop again is going to be the same loop that we have on the outside. We now need to loop here as well. So basically what we're now creating is that support loop and just ignoring everything else and connecting it down. So again, main reason for all of this is kind of like to showcase why basics, or why having a strong understanding of basics is going to be kind of like the crucial for creating anything complex later down the line. So again, now we have this here. And here's another kind of like thing. Here we have another triangle, which now we can solve a couple of ways. So let's say that one way is going to be, let's say, continuing this loop, I don't know, somewhere here down at the bottom, which is going to kind of like create that classical 3-to-1 connection where you have 3 edges flowing into one edge. I'm going to not use this for now, but instead what we're going to do, we're going to sort of like wrap it on the inside. So like use it as an additional sort of like support loop here on the side, because simply we can afford that and just going to use it that way instead. So this can also then, let's say, be a little bit closer. So we can afford that here and it's going to be just as fine. So now the question is here on the top, what to do with this. So the rule is going to be that these points that we have here on the top, how high or how low. So for example, if this is too low, we're going to have pinching. So we're going to leave it, let's say, somewhere like here, so that more or less that we are getting kind of like the same size polygons on all sides. So this is going to be sort of like the guide for what is going to be the distance from it all. So again, back to those basics. And there we go. So now we have that. And this we can push a little bit more down. And then here we're going to balance everything with, and then just here balance everything with a couple of edges. The only kind of like, it's not really an issue. So triangle is not in itself really an issue, and we can fix that still later down the line. Let's now continue with fixing the parts that we need to kind of like bring back. So we need to now mirror this. And this is going to be on the object and it's going to be on the z-axis. All right, so now that we have that, let's bring back everything else. So I'm just going to realign everything. And this is going to be, again, mirror on the x. And let's do one more. So it's going to be mirror on z. One thing that I actually forgot is the opening on the top. So we can do that. So I'm just going to use here. So like small extrusion, and let's do it one more time and extrude it in, and we can also delete that. And it's just now the part of bringing these support loops together. And yeah, that is all. And now is the part with also, before we do the mirror, we need to simply deal here with the triangle, and simply we can delete now this loop right here, and from there we're gonna get a quad, and we can then mirror this on the, so even if you left a triangle here, it's again still not a big deal. The only thing with the triangle is that it's sort of like breaking the flow, so you're gonna need to redirect it if that is again something that you would want. But if you do not want to have your flow interrupted, then simply delete that one. So yeah, mirror now back on the z-axis. And then the only thing now I would need to do here, so since I deleted this, I would need to circularize this back, remove the symmetry, and offset this a little bit more, and just recreate so like that little detail there. So it will be something like this. Doesn't really matter that much, so just delete and bring it back. So yeah, so now when we have that, what we can do is maybe detach it from here, depends on how much of a thickness we want to have. I'm going to reset the pivot, and basically now what we're doing is kind of like mirror it on the y-axis, depending on where the object is sort of like located, either in the world axis or wherever you want to set the pivot on. But I'm going to mirror it here on the world y, and just, let's say, connect the parts like this also. So just bridge them together. So if you notice something like this happening, so if you're kind of like using a bridge and it's twisting, you can use twist. But even if if twist is not helping, what you can do is just bridge one and then bridge the rest. So that is also going to be kind of like the same. And in this case, I'm just going to kind of like redo the loops, and there we go. So that's kind of like the whole piece sort of like deconstructed what we had there at the very beginning. So the process, as you notice here, is exactly the same as we had before. So everything sort of like starts with that deconstruction of the parts that we are not really sort of like clear on. And once we are clear on the parts that we need to do, so in that case, it was sort of like the breaking this piece right here. So breaking this one, and breaking this one. And so like the practicing only on this piece alone, just to see what kind of like edge flow would we need on these parts. So once we are familiar with that, so once we sort of like practiced all the possible flows that we can get on this corner, then we're sort of like prepared before even creating, let's say, booleans. We already know what to look for, and then we already know how the final shape is going to look like. So regardless of the complexity, one more final time. So regardless of the complexity of the objects that we are creating, the process is always going to be the same. So it's either, let's say, you're creating a caliper for a car, or creating a car itself and you're trying to model a car in its complete form. Try to simplify it to the forms first which you do not, let's say, understand, or the forms that you might think would be the most challenging. So let's say that being it a rim or a caliper or a tire or just a door or just even a door handle. If you're, let's say, see an object like this and without even thinking too much, that you know where to begin with, or that you, let's say, understand what the biggest challenge of something like this would be, just try it from there. So demystify, let's say, the parts that you feel that would be the most challenging. Those can be from the simplest, like even, let's say, this opening. If you're not sure how that opening would work, again, what you would do, just a small kind of like recap, is you would just take a general cube and try to mimic that corner. So you would do, let's say, this. It doesn't have to be, let's say, perfect topology or anything. It can be just that you're focusing on the shape. So just focus on, okay, I'm trying to get that shape first. So here I'm creating that form. And let me now try to figure out what the topology around it would be. And that is going to be, let's giving yourself sort of like these small case studies so that you know, okay, the topology around this object is going to be, let's say, like this type of density. So that means once I see this object on something more complex, I already know what level of topology I'm going to need for that, what kind of like flow of the edges I'm going to need to have around that area in order to create that detail. So basically it's going to be just like that, breaking the complex parts into the smallest ones, to the smallest ones, to the actually the point where you feel that this part is going to be challenging. let me break down that challenge for myself, let me resolve that challenge by challenge, and kind of like combine all of these challenges together that are resolved into one solid piece at the very end. So I hope that makes sense. And yeah, like I mentioned, some of these parts, like I know that this one and this one for sure we covered on this channel. So if you want to, you can just see the workflow behind those. Finally, I also don't want to do any special advertising here, but feel free to check my topology workshop where you go really deep dive into how topology works, and like we talk about a lot of examples, a lot of cases, to sort of like almost unhealthy obsessive levels to the topology. So if you want to, yeah, feel free to check that out. And yeah, like always, thank you very much for watching, and I'm gonna see you next time.